Hi, my name is Emmanuel Coronel and my topic is about
Bellows. What is a bellow? It's a flexible element which is used in piping system to absorb expansion or contraction, deflection or bending in a piping system. Here are the three basic movements of a bellow. The first one is the axial compression and elongation. Next is the angular movement. And the last one is the lateral movement. Axial movement of the bellow is the change in dimensional length of the bellow from its free length in a direction parallel to its longitudinal axis. Bellow expression is expressed as negative and bellow extension as positive. The unit for axial spring rate is Newton over millimeter. Lateral movement. Lateral movement is the relative displacement of one end of the bellow to the other end in the direction perpendicular to its longitudinal axis. Lateral movement can be imposed on a single bellow but to a limited degree. To get more lateral movement, two sets of bellows shall be a better solution. Unit of lateral spring rate is Newton per millimeter. Angular movement. Angular movement is the rotational displacement of the longitudinal axis of the bellow towards a point of rotation. Convolutions at the innermost are in compression, and the convolutions at the furthest point are in extension. The unit of angular spring rate is Newton meter over degree. Moving on to the application of a bellow. An example is a system that's not properly anchored and guided. When you introduce some flexible metal bellows and pressurize the system, it is going to push over the piping. That's because of a pressure thrust load, and another is a straight piece of piping, same thing that in load, that is going to buckle piping and it's going to kick out of place. When the pipe is internally pressurized, it has a pressure press force. You just don't see it because it is resisted by the stiffness of the pipe. That pressure thrust is equal to the cross-sectional area times the internal pressure. Now, when we pressurize the flexible metal bellows, that pressure press is not resisted by the stiffness of a pipe, and so it's allowed to grow. The pressure thrust is causing that bellows to grow, and it is that the force that causes a system like one in the elbow here to be pushed over and bellows to elongate, and both of these are problems that we've seen the field on startup when systems are not powerfully to design it with anchors and guides. Now, to prevent this from happening, In a straight piping system, a couple of guides on each side will prevent the straight pipe from buckling in and allows that pipe to go straight into the expansion joint even though it's exerting a pressure thrust. Here, the most common type of guide, called the spider guide pipe, are clamped around the pipe and are fixed through the pipe, and they move along the pipe, and the outer sleeve guides that pipe and keeps you where it wants to be. Going back to the previous unrestrained piping system, you've got a bend in it, so what we do is you drop an anchor at the bend part, keeping all that pipe straight, and we drop in our guides, and now we have an unrestrained expansion joint system. Another example is a steam power plant. It consists of four major components: the condenser, boiler, turbine, and generator. Water using coal, fossil fuels, or gas is superheated within the boiler steam. Is then thrust through the turbine to generate electricity. The steam is then sent down and to the condenser and back to the boiler to repeat the process. When metal becomes hot, it expands, which without an expansion joint would cause the pipe to break off of its position. The bellows is a piece of flexible metal that, when the metal pipe begins to expand, will compress on itself, alleviating the stress of the turbine. In the boiler, when the pipes pull down, the bellows return to the original position. The balance joint is an extended piece of pipe on the end that directs the expansion of the main pipe. Holes in the main pipe allow the pressure from steam to fill the balance joint. This pressure counteracts the internal pressure, forcing the pipe to expand towards the bellows. Together, this allows for a more efficient system for generating electricity.